Okay, so let's learn about how the light create images. So images from formation and applications. So light is a really interesting wave that behaves nicely creating images. So the light can reflect. So reflect means when the light enter into a surface, it can bend back again into the same medium. So here, let's say a light is incidenting from air. So here it's filled with air in this region. So the light incident from the in the air to the surface, and then it's get reflected back into the same region. So here the angle of incident is equal to the angle of reflection. So we call this as the reflection when the light come or the incident and bended back again into the same medium. So this is the reflection, and important factor is this angle of incident is equal to the angle of reflection. Then, so you know, like light is a wave. So if you think about the light, you feel like it is a ray, but it is a wave as well. So it is, light is really wave. It is often used to describe in terms of rays. So you're using rays to describe the light, but it is really a wave. So you may think about wave fonts like peak points. So the like when it's hit onto the surface, it's get reflected back. So those waveforms will be reflecting back, right? Then the other scenario that happened with the light is the refraction. So if you have ever noticed this type of scenarios in your natural life, like you have a straw in a cup or a pencil in a water cup, you will be seeing the pencil is broken, right? So that's due to the refraction. So the refraction of light happens due to the speed of these waves. So when the light travels in different mediums, it travels in a different speeds. So when the light rays enter into a different material like glass or water, we feel like maybe you have noticed that the light is bent, right? So the speed of light in glass or water is less than in air or vacuum. So the distance between those waveforms that I mentioned earlier will be shorter. So it does have a shorter wavelength when it's going into the denser material like glass or water. Then the index of refraction is the identity of this refraction quality of the materials. And you can calculate that by dividing the speed of light in vacuum by the speed of light in the substance like glass or water. So in glass, it travels slower than water or air. In water, the light travels faster than in the air. So likewise, depending on the material, it does have a different speeds. So here's some index of refraction for some materials. So vacuum refractive index is 1, air is about 1 as well, water it's 1.33, in ice it's 1.31, in glass it's about 1.5, and in diamond it is 2.417. So this refractive index gives the internal reflection of light in diamond that's make the diamond expensive. So when the lights are reflecting, it follows some laws. So here, if you think about very small angles, the refractive index times this angle is equal to the refractive index of the second material times the refracted angle. And also the light does do dispersion. It's a part of refraction. So when the light travels into a different material, like with different refractive index, so the wavelength will be different. So different wavelengths are bent by different amounts. So you know, like white light is a combination of all 7 colors. So that's why we see the rainbow colors, right? So when the white light hits the prism here, it is a glass material. So the blue color bends different than the red light, right? So shorter wavelength light, which is the red color, bends little small than the blue color. Blue color light bends more. So you see the blue color at the end here and the red color at the top. So we, as I mentioned, different wavelengths are bent by different amounts. So the wavelength is associated with the color that we preserve, right? So the red color has 700 nanometer wavelength, and while the blue or the other end colors have 600 nanometers. So blue light is bent the most and the red light is the bent least. So light is bent toward the normal as it enters a prism and away from the normal as it exit from the prism, because it's going into a lighter material when it's emitting back into the air. So as you see here, the blue rays are bent the most. This is called the dispersion. So it's a part of refraction, but different colors bend differently in the same material, right? So that's called the dispersion. So we see rainbow formed in the sky. So how do the rainbows form? So, you know, like rainbows can be seen either just sun rising and sun setting with the presence of kind of water molecules in the air. So if there's a rain happen, not the heavy rain, but light rain, and then at the same time, if the sun rises or sunset, then you can see the spectrums, right? So the rainbow happens when the water molecules are present in the air. So water, it is a water droplets are making a very thin film water in here, but inside it's air, right? So when the sunlight enter into the water bulb or the bubble, then the light will get dispersed. And here again, there's a water barrier and the air in outside. So in this point, it will get reflected, and again, it's refract over here, right? So the refraction happen when the light enter into the air droplet, and then reflection happen in the other side of the droplet, and then when it's coming back into the air, it's refract again. So you'll be seeing rainbows over here. All right, so let's learn about telescopes on Wednesday. Thank you.